Deepest apologies for not having sound. Take two. So this is the procedure and equipment needed to run experiment 10, the determination of an equilibrium constant for St. Lawrence chemistry in the spring. So to start off, we're going to go over our equipment. The equipment we will need for this experiment is a 50 milliliter and 10 milliliter volumetric flask for creating our standard solutions, and we're using this because it is accurate enough to measure to the degree we need to. We need two 50 milliliter burettes to accurately dispense the solutions into those volumetric flasks because these are, again, accurate enough for our measurements. We need 4 beakers of at least 50 milliliters to hold our solutions after we make the solutions. Then we also need a cuvette and a spectrometer for actually running the experiment itself and testing the absorbances. We need a pipette for transferring our solutions into the cuvette from our storage beakers. We need 3 test tubes to hold the solutions we create in part 2. And these are small enough to hold our 10 milliliter solutions. And then we also need parafilm, obviously, for mixing, and a pen and pencil for recording our data. So now, with that set, we can go on to our procedure. So, for part 1 in our procedure, we want to rinse 2 50 milliliter burettes and fill them with one with 30 milliliters of 0.2 molar FeNO3 iron nitrate, and the other with 20 milliliters of 0.002 molar SCN. So we want to fill these up, and then we want to set them on their in their clamps and release the air bubbles and drain both to the nearest milliliter mark so that we can accurately measure they should be dispensed into a waste beaker. Now what we want to do is add the listed amount in our procedure of iron nitrate and SCN to the 50 milliliter volumetric flask. And then we want to fill it the rest of the way to the fill line with deionized water so that we can use our water for and our pipette towards the very end. Then we want to take parafilm and mix and invert it and pour it into a clean beaker of at least 50 milliliters and label it with the concentrations we put in using a grease pencil. So then we want to repeat those steps 4 through 6 of creating each solution for each listed amount of iron nitrate and SCN. So after we've done that, we want to blank our spectrometer with a cuvette of deionized water because that is our solvent in this scenario. Once we've blanked it, then we're going to measure the absorbance of each solution in the spectrometer and record the theta max. And when we do this, we want to rinse the cuvette that we're using in between each solution. You want to rinse it with the solution you're going to be putting in and then filling it so that we don't get any diluted solutions or any issues with our measurements. So then, after that, we are going to measure the absorbance of each, record it, and create a standard curve in Excel and record the equation of the line in our packet. So then we will go on to part 2. So in part 2, we are going to want to fill we're going to want to fill the 0.002 molar SCN minus with 10 more milliliters in the burette. Because it is the same concentration, we can leave it as it was and just add more. And then we're going to want to rinse out the 0.2 molar iron nitrate burette and clean it out, and then fill it with 0.002 molar iron nitrate because that's what we will be using for this part of the experiment. And then we want to do what we did before by placing it back in its clamp, releasing to remove the bubble, and lowering it to the nearest 1 milliliter mark for accurate measurements. So then we want to, much like we did in the first part, release the listed amount of iron nitrate and SCN minus into a 10 milliliter volumetric flask this time, and fill the remaining space with deionized water. Again, using our bottle and our pipette that you will have cleaned if you used it in the first part, which you should have. Then we want to mix the solution with parafilm and pour it into a labeled test tube that we've set aside. That's what those 3 test tubes were for. We should label those with grease pencils so as not to get them mixed up. Then we want to rinse the volumetric flask out and repeat for solutions B and C listed on here. Also, in part 1, there should have been cleaning of the volumetric flask between each solution. So then, in part 2, we're going to pour each solution into a cuvette rinsing the cuvette with each solution before filling, similar to the way we did it in the first step, just this time coming from test tubes instead of beakers. And then we're going to, again, measure the theta max and record the absorbance. So then we're going to use the line of best fit on the standard curve that we created in part 1. We're going to calculate the equilibrium constant of FeSCN2+. So then we're going to use the concentrations in an equilibrium constant equation to calculate a value for K. And that is our experiment this week.